recording. All right. So we were looking, well, I guess we're a little bit early still. I should bring my trivia cards in. But I don't know how much to. Wait for that last person to get, oh, yeah, somebody's. Hello. A fair number of people, all right. Yeah, we're just talking about kind of kicking things off. And the problem with the visual, I find, visual programming tools, whether it be, I use Max MSP a fair amount, and Bolt and so on, you do really develop much more of a, almost I don't want to say physical, but a memory for where things are laid out and how they are, and like this kind of relationship to where things, and one slight change in the interface has way more of an impact on me. I find that, like, if you change some syntax or added something, some new thing in a programming language, a feature of Visual Studio or something, I wouldn't be as thrown off as I tend to get if you throw me off in a visual programming tool. So the main one being, it used to be, not that long ago, in Bolt, that it would, by default, it would include in your flow graph window, and it would kind of happen, I think, automatically, and maybe it's just because of the size of my display now or something. They would be kind enough to put the graph inspector would be over here as part of this window. And also, there's two important things: the graph inspector and sort of the blackboard of variables. Important to have while you're working in Bolt. Over on the side there, especially until you kind of really get going on a good graph here. And things like, because it's sort of hidden, like in our case of our super unit over here, we were trying to create a subroutine, right? Basically some sort of function that was within our graph here, so that it didn't wind up with kind of extra code in there to make this, reduce the amount of visual spaghetti. And we got there, and then I couldn't remember. I was clicking on input, saying, well, where's my set for my actual things I want to have as inputs? Or if I click on my output, how do I set that up? Because they had done away with this, the fact that the inspector would normally be part of that window. So I had to eventually remember to go and get that window, set up a new layout. So now, in the case of a super unit, which is our subroutine, you have to find the graph inspector so that we can inspect our input or output values and decide what things need to be input or output. So in this case, we have a control input, which I named flow here. And control input, you have some number of ways that it can take something to continue program flow. So you could say, well, I could have a couple of inputs if I wanted. Right? If I had multiple paths that I could go through, which would almost be like having multiple entry points into a method. How do we do that in C#? That's kind of an interesting thing, right? I could have another input here where I had condition 2, for example, right? And some other chunk of the code, it jump into the middle of this method or jump into some other part of it. That's not something I would be able to do in a, not easily. I can't imagine. Yeah, be multiple methods, but now I kind of have this way in here of creating this kind of inside. It's just interesting, if I want to skip over the initialization of something, I could do that, like have some kind of thing. First time it's called, call this version. Second time it's called, or subsequent times. Which I guess is a lot like, on start you call this, on continue do this, on exit do that, which is a little bit of a hint to how I'm going to show to do a coroutine in here using a state, a little bit of a state machine. So anyway, that's the proper way. So now I could say, well, this super unit has a flow input, so I can tell it to run, execute, do whatever you need to do. And it has an output which also only has a control output. So it does everything internally. It basically, what should be happening, which isn't, right? Set variable, I'm setting the speed. Oh yeah, this is, okay. So I need an output here. That's why it wasn't working before. I need an output, so I'll say speed will be my output. And I need a type. Call it a float. And this is, I find this to be concerning, that I am basically setting speed, but then I can't just say, well, let's pass this through here. But I could do this, which is odd, that I want to basically add a unit that's my speed variable. So I'm going to get speed and pass that out. So this is a little bit odd. And there's probably some other way to do it. So at input here, I get whether or not the Z key is down, and it decides if the Z key is pressed, I will either set my speed to fast, if Z is pressed, or I'll set my speed to slow if the Z key is not pressed. Right, so setting this value to whatever is set there. And then after that set, I output speed by getting speed and sending to that one. A little bit odd. I would have thought maybe I should just be able to, since this is passing it here, I feel like I should be able to do that and that, but it doesn't want to let me do that. So the way around it, I guess, is to do that. And you sort of have to think of it, at first it feels to me like I'd be, oh, there's got to be lots of overhead or something there. But this is really just referencing that variable. It's like saying return foo or return speed. Ultimately, that's the code that it winds up being. So it feels wonky, but I think in the end it's okay. It's just ultimately referencing the variable by its name and saying return speed. Weird. So that was my check Z super unit, and now I'm going to go back to my light bandit graph here. So sure enough, now I've got here, and speed is coming back, and speed is, well, I guess I could just do this now. So the value is being returned, and it's being sent to this holding spot. It's also a little bit weird. I have effectively a return here, but then execution continues here, but the returned value is kind of kept in a little space until I wind up needing it over there. Also a little bit interesting. how it must be doing all this fun stuff. All right, so that's my super unit, and let's see if it actually works. So, and the age-old problem of the flow graph taking up too much space on the screen. It seems to be running. And if I hold down the Z key and press D, it moves pretty quick. If I let go of Z, he moves slower. All right, so it's running. It's working okay. Now, also running at the time, if you look over here and we look in the console, you'll see that there's a hello message being printed out there every second, 16, 17, 18. You can see the seconds counting off. So I decided to do, how would I do a coroutine in Bolt? So one recommended method, and this seems to work nicely, is to use a different type of unit. Rather than a super unit, we use a state unit. And this state unit looks a lot like a super unit, a little bit different, in that it has a enter, exit, and update event kind of baked into it. Right? Normally a super unit, just has, you decide how it flows in. So this really doesn't have a traditional or typical program flow. This actually has an event that's going to trigger certain parts of this code. So if I double click on this now, we'll see that the on enter state, so when this thing is started and this state is entered, this is what happens. So the first thing it does is call its monobehavior print, passing it this string that's hello, and then it does a wait for 1 second. And so we have a loop here, one of our first kind of fun loops. A little bit ugly. I think there's got to be some way to... I need to add like a dummy node. Is there such a thing as a dummy node? No. Functionally, I just drag this to here. So it loops back to the print 1 second later. Right? So here we have this potentially infinite loop. Waits a second, prints the message again. Waits a second, prints the message again. Waits a second, prints the message again, sort of infinitely. If I wanted to be fancier, more like the coroutines we've seen, I could put a for, some kind of structure outside of there. Add unit for. So here's a for loop. So we would say, all right, don't call this infinitely, and instead we'll enter this state, and the body of this will be there. And we don't have an exit. So we're going to actually get rid of this line here. I think that's right. So first is 0, 10 is last, step by 1, and I think the body will now be triggered basically 10 times. How is it waiting for? Let's see if that does work correctly. That makes me feel weird to not have that passed in here. I just want to see it, then it'll just execute right here, maybe. Get lucky? No. So it's running. Let's see if it stops after 10 iterations or so. And it stops. All right, so it did do the right thing. So I would have my whatever was done exit the state, exit the coroutine there. There is one other thing you need to do, though, for this to be a coroutine. If you just kind of followed this directly and didn't do anything else, it would complain. And it would say, well, you can't do this wait in here unless you're doing it inside a coroutine. So how did I make this a coroutine? And basically, I had to tell it this on enter state. Shift this off a little bit here. You notice there's a little indicator here to say, run this event in a coroutine, enabling asynchronous flow like wait units. So I have to tell it that this state is spawned as a coroutine. So basically, when this is entered, it is entered using our familiar start coroutine thing. So there we have it. Some kind of high-level important things to be able to do. Use coroutines, use the input and output. One thing I realized that is tricky, or I haven't figured out a way to do it, maybe there's just no proper way to do it, and this was on some resource I looked up. Doing inheritance is really kind of, there's no way to just like inherit derive one class from another class inside of Bolt. So that's kind of a limitation if you're doing things in Bolt. But a lot of people get away without ever using inheritance. Maybe that's on them. But that is one kind of major difference. You won't see that sort of structure. I mean, other than doing it, you can always like copy and paste and so on. Kind of do a has-a instead of an is-a kind of approach to things. An argument I saw in favor of visual programming is, well, because you do have to sort of plan it out. You have to see what's going on, and everything is more like in your face. It forces a certain discipline on you if you implement things this way. Kind of, sort of, I feel like I have to be more careful and deliberate a lot of the time. And then I sit down and I'll like space the code out and look at it and make sure things aren't, calling. So there is a certain visual debugging, deliberation aspect of it that maybe that's a reason not to get too not to be too dismissive of it from put my nose in the air as a traditional text-based programmer. In the end, I think the other video I watched, Infenzia, in case you haven't seen, I linked to it here. I'm a big fan of this YouTuber, Infenzia, and he did a video on Bolt versus C#. He kind of comes to the same conclusion at the end. Is he just does things real fast in C#. I like Infenzia a lot because he does he approaches it from his videos, a bunch of different angles. Does a lot of Blender to kind of Blender pipeline through Unity. So if you're interested in going forward, we're not going to really do 3D games. I'm going to talk a little bit about it, introduce some of the concepts, how you can do some things. But he does a lot of low poly modeling and then rigging and kind of using 3D in Unity, which is really cool. He does also a lot of like 10 minutes to create a whole thingamabob, whatever, a boat, 10 boats or 10 animated characters in 10 minutes. Really, really nice guy. Also does a lot of game music and things. So he's, I don't think many of his tutorials talk about the game music, but maybe that's just him. So highly recommend his channel, especially if you're trying to make a jump from 2D to 3D. It's kind of really good. All right. So any other questions, thoughts, comments, debate? Anyone want to say, yeah, this is, I mean, I like that notion of that jumping into code, that kind of weird, having kind of basically labeled points in there. That one is an interesting, I mean, in traditional code, I don't know if you do it in C#, but certainly in other code you could set labels and jump to a label. Now I'm getting really showing my assembly language programming kind of roots. I'm not afraid of go-tos. I'm okay with that if you need to. But this is sort of, opening up the bucket. Without calling it a go-to, it's effectively, you can kind of create these kind of go-to weird things where you jump into the state and go to here. Ooh, blasphemy, blasphemy. All right, so that's Bolt. Now, if I manage to find the right place here, The Unity store. I'm making a plug for, I'm spending a bunch of time in the Unity store, and there's actually, along those lines, if you're thinking 3D and so on, I'm going to recommend there is an asset called UModeler, which is on sale right now. One reason I wanted to mention it, but there's a UModeler Lite version as well, and you can grab that. If you do wind up doing any, or want to do some 3D, or create some simple assets, or create a 2.5D. We'll talk mostly some examples about like 2.5D, how to kind of simulate and fake 3D in certain games like we've played. Anyone played Inside, or what's the other game by that same? I can't recall at the moment, but you know, things that kind of combine a little bit of 3D and a little bit of parallax. Limbo, yes, Inside and Limbo, two really, really great games. And I think they used the Unity engine for either one or the other. I can't remember. I don't think they used it for both. But UModeler Lite is a really cool asset because it sort of basically jams a lot of Blender-like or 3D modeling capability directly into Unity. So we may wind up using that tool in a couple of classes, just as sort of expo, we'll call it. You know, and if you want to include some assets like that in there, it's kind of cool. So. Yeah, I guess it's running. The sale is ending today on that particular asset, so you'd have to like try it out and then decide real quick if you want to get the full version. One of the reasons to get the full version, and if you're doing everything in Blender, don't worry about it. But the one big thing that the paid version does that the Lite version does not is texturing. Right, so if you want to create textured 3D models, if you want to have, actual, physically based PBR, or even just straight, simple albedo textured models, you would kind of have to do that in the fancy, expensive version, which is now $62.50. I view it as sort of one of these must-have, almost must-have Unity tools there. You can see here, rigging in Unity. So, very cool. All right. And let's get back, not to platformer design, but all right. Now, big question. I'm not like totally doing a brain freeze, and did I talk about grounded platforming? Okay. I'm this 8 semesters of straight with no break and pandemic. You're just like, is it 8? I don't know. It's a bunch now. It's definitely wearing on me. And anyway, so platformers. We're into platformers for the last thing. And this goes whether you're doing 2D or 3D. The concepts now are going to be similar. If you're going up, down, sideways, doesn't really matter. The idea is platformer. What does that mean? You're standing on something. That's kind of the real idea. It could be a top-down game. You can have a top-down platformer, essentially. It's more about this notion of, you're classically moving from platform to platform. Crash Bandicoot was a really great 3D, one of the first, kind of pinnacle of great 3D platforming games. And of course, a lot of the Mario, early N64 3D platformers and so on. So you can have, that type of game as well. And it largely has to do with that jumping from platform to platform or level to level. That's where they're getting their name. And one of the key things about that, of course, is, well, now you're not just saying, move with this velocity in a certain direction. There's some aspect of gravity that has to be included or dealt with. So what I wanted to start off with here, we can just throw this out there as perhaps the most basic 2D platform character controller that I could come up with. The notion of just being able to go, okay, move left and right, but jump, but jump. We have some sort of jump. We need to have a rigid body on our character, and the character has to be able to move, and the character can jump. So it's a matter of saying, well, the input vector that we get from getting our axis, you'll see here I'm actually kind of grabbing during in update, and I've separated this out, the part I would do in the update routine versus the part I would do in the fixed update routine to kind of keep the sort of physics, actual stuff cleanly separate from the user input. So the first half there is getting the input vector, and I just grab both horizontal and vertical because that's what I like to do, and that's kind of the way the input system is set up. And the extra bit of information we need, of course, is whether or not we're going to jump. So we have a mapped button in Unity through the Unity interface. It has a defined button input called jump. And by default, that's the space bar and certain joystick controller buttons as well. So inside of update, I just say, well, all right, set that input vector and set this Boolean to true, meaning the user has pressed the jump button. And I specifically get button down because I only want it to happen once, right? The initial press. So if you want to double jump, you have to press and press again. Triple jump, 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 jump. Right? That's one thing. We always talk about, we start getting to double jumping. Someone asked about this. Coyote time. What is coyote time? They're hoping that they did it on the project, but yes.
Oh, yeah, it's when you run off the platform, you can still have some grace period to jump.
Yes, the classic Wile E. Coyote in Warner Brothers cartoons chasing the Roadrunner, and all the time the Roadrunner, the Roadrunner would potentially run off the cliff and somehow never fell, but Wile E. Coyote would wind up running off the cliff, usually through a tunnel or following some train tracks. And there'd be that moment where he would run off and be suspended in midair for some amount of time. Wouldn't immediately start falling. So he could run back. He never seemed to run back. Sometimes, once in a while. But usually it'd be a run out, and then you have some time to react, and then fall. That's coyote time. So this right here doesn't account for that just yet. So you would have to take some of the techniques that we're going to talk about today, implement that. So in fixed update, now we have this extra piece around here, if grounded. And we don't really show what grounded is yet in here, so that's the missing piece of this basic platform controller. If we took out the grounded, we just said, okay, set the velocity according to our x and right motion, and you'll notice it's setting the rigid body velocity.y to be whatever it already is, rigid body.velocity.y. So it preserves that, doesn't change it, doesn't add it, doesn't set it to 0, doesn't do anything to it, because we want gravity to be respected. If I just set it to 0, that would cause it to be floating in space. Anything that was accumulated with gravity would go away. Right? So it's important to remember that I am, in this case at least, I'm using the input vectors x times speed. So I am setting the rigid body's velocity to some specific value with regards to x velocity, but just preserving the y. And this being the simplest one, it doesn't take into account things like, well, what if something exploded next to you? You needed to be pushed. That goes out the window with this one, right? Because if we're just setting the x and y velocity, or x velocity according to whatever the joystick is. So, well, we'd have to get fancy if we want to, kind of do that, to figure out, okay, is that a force that gets added? Do we, instead of manipulating the rigid body velocity directly, are we adding a force every time you press the joystick? That sort of thing. Now, in the second part there, we say if jump. So we are acknowledging the fact that the jump Boolean, the jump flag, was set to true, and we jump. We jump by setting or by adding to our velocity some upward. So we say, okay, for some brief moment, we add 10 upward, basically, to its velocity. We overcome gravity. So if we're standing somewhere, gravity, our velocity is 0 because we're on some surface. We would immediately come back up, and a second later, gravity would overcome that because gravity is 9.81, roughly. Or that's what gravity is, roughly 10. So gravity will be overcome a second later, and we'll come back down again. So we'll push up, and then gravity will take over again and push us back down again. And then I set jump equals false. So what is the purpose of that if grounded? Anyone? Infinite jumping, right? Should you be able to jump when you're in midair? Right? Some games let you do that. Sometimes, double jumping is allowed, but not triple jumping. Playing a game, It Takes Two right now, where double jumping is cool. You can jump, double jump, or jump and dash, but you can't triple. You have two actions, right? Until you touch the ground again. Or potentially if you touch the wall, or you touch the ceiling, grab onto something, right? So there's some notion of you have to have interaction with the environment in order to say, can I do more action? And that's, because you shouldn't be able to be in midair. And just, physically that shouldn't happen. So even if we just do a simple double jump, that's sort of like coyote time a little bit, right? We're jumping in midair. We're jumping off the air, which is a little bit of a violation. So this is the notion of groundedness. The player can only walk, jump, run when touching the ground. All right? So can the player double jump? That's up to you. Can the player climb or run up walls? Up to you. Can the player hang or shimmy overhead? If it can grab onto a surface. Can it rock climb? Whatever. That's all up to you. Right? So it's a matter of what behaviors are allowed according to groundedness, wall touching, overhead, and so on. Right? How do we know if we're grounded? How do we check for the ground? Right? Pardon the pun. Every so often I think I come up with a really great one. All right. So one thing you can do is if you want to have separate behaviors for ground, jumping versus climbing versus shimmying and so on, you can do things like use different physics layers to distinguish different types of relationships. Right? You can determine what is the ground, what is a wall, what is a ceiling. Right? Maybe things are both. If it's a platform and you touch it from beneath, well, now you got to get fancy. Right? It's not just enough to say, are you touching the ground? What angle did you come up from? Now, one assumption here is that we start using things like casting. We've talked about casting with regards to like putting something into the scene. We do a circle cast or a collider cast to say, okay, what things am I going to hit when I'm in the scene? Or can I see something? Can an NPC see me and sense me for purposes of AI? Generally want to use our casting functions in a similar way, right, for this sort of thing. You could, the first naive approach, one I tried, one everybody tries, I think, is to say, well, what about just using colliders? Right, what about just saying, well, okay, did I collide with the ground, therefore I'm grounded? If that sort of brute force thing is all you need, great. There'll be problems like, how point of contact, how do you bounce? Are you, do you momentarily touch and so on? I find personally collisions to be a little kind of wonky to kind of do that, and especially as you move from object to object, or you're kind of walking along a surface that, you might have some kind of transition, and you were touching this, and you exited that, and, yes, you hit it, but then how long are you grounded? You only got the message, so you just try to set a flag on your first collision. So do you change your groundedness when on collision exit? Maybe that kind of works. But what happens if you get an on collision exit from one thing after you got an on collision enter from the new thing because your collider happened to be square? All right, let's see. Here's a good, I'll draw a picture and I'll try to explain it for those of you playing along at home. Imagine you have two squares or two platforms that are separated by a tiny little gap, right? One on the left, one on the right, and you have some sort of your character with a box collider currently on the left platform. And your player moves on to the right platform, right? So it moves here, and eventually it exits, or let's see. The moment it crosses that little gap, it's actually touching both, right? So now it's straddling that gap, this part here. It's that little in-between is straddling the gap. So we just got a new on collision enter 2D, whatever, because we hit the new platform. So we're on the new platform by just enough. And we continue to move. And eventually, we get to the point where we just exit this other collision. So we get an on-collision exit. So we might think at this point we're no longer grounded because I just got an exit. Because the other enter, on-collision enter, happened before the exit, but I exited the old. So it's a little bit potentially confusing, potentially problematic to just use colliders when it comes to being grounded. So I recommend, and I think the general consensus is that a better way to do it is using some sort of casting. So we can use orientation, for example, and we might have multiple things. We're not limited to only one cast or even casting in one particular direction, right? Touching anything can cause grounding, but what you might need, well, for that we might need to do a little bit more math. We'll see in a minute. Okay, so you could, for instance, cast something and say, okay, I have a collider, I have a box, I have a circle, cast it from the center of the character down. And if it's something, well, that's being grounded because I cast it down. You might then also say, well, okay, if I didn't hit anything down, maybe I should check to see if I'm hitting anything up. Cast it up from the center of the character up. All right, that means I am hanging if I touch something that way, right? You can also even find specifically the points of contact if you want to get really, really fancy. So a lot of the time, ray casting immediately comes into play here, right? Check to see what overlaps an arbitrary ray. So we can say grounded equals ray cast, we point it down, and we hit the ground. However, one thing to be aware of if we're doing ray casting or line casting is rays are just a sliver, right? It's just a tiny, tiny thing. It has no width to it. So a ray is just a sliver compared to the actual point of contact, and can lead to false negative results and stuck objects if they're, again, kind of walking through these kind of things. You want them just off, and I'm actually, my feet, I think I'm over there, but you only cast this tiny little sliver down. So sometimes it's better to do something fancier, like overlapping circles, perhaps. And you could say, well, all right, is this circle overlapping with something called ground? Maybe you have left and right. Say, oh, am I overlapping with something I can climb with? A circle at the top, something I can climb up with. Now, additionally, once the physics system is doing the work, turns out there's all sorts of kind of state inside there you can also get at. So yet another way. At any moment in time, you can check to see what layers any particular collider is touching. So this is one where you could say, well, am I touching any layers at all? So my case where I was straddling things, because it's it's a polling sort of thing, it's asking, right now, what am I touching? I could do this potentially. I could say, well, am I touching anything that has a collider that is on the layer called ground, right? So I'm using my collider to see, is my collider touching anything that is on the ground layer, right? So that's an interesting one, right? Another approach. Rather than casting, you could say, well, what is the current contact? And there are even more ways. Once you're touching the layer, you can actually get those points of contact. So you can see precisely what the collider is touching, precisely where it is. You get the specific points of contact. This one is fun, because now you can do things like determine, am I touching on the bottom, am I touching on the top, am I touching a little bit over to the left, a little bit over to the right. So you could check for sort of diagonal points of contact. Is the back portion of me, is it ahead of or behind my center that I'm contacting? So the idea of like teetering or being on the edge can come into play. Right? So here, check for the point of contact if it's below, if it's 0.1 units or 0.1 meters below the center of the hero. That's what that would say, right? If that point of contact is below the hero. Another possibility, a million of them, or at least I think I came up with like 6. Cast the collider in a direction to see what it hits, right? So if you know you're using a circle collider and that's really what your player's kind of used to dimension-wise and so on, you can use the collider, the character's collider, and cast that in a certain direction. And that will give you precise information. So for example, we can use, you have to set up what's called a contact filter, which sets up your layer masks. So now you have to kind of tell it what things are you interested in casting your collider against, what direction you're casting it in, right? So you're moving the collider within the scene to see what it touches. Right, so we can cast it down. This is basically, you can kind of think of this as anticipating the motion. Right? So if I'm anticipating moving down, this would tell us what I would hit if my collider was to continue moving according to my math here. Right? Here I'm just moving it down by 0.25, perhaps. Or no, sorry. This is vector 2 down. So I'm moving down 1 meter. If I continued moving down 1 meter, this is what I would hit. If I moved to the left or right, what would I hit if I kept moving in that direction, moving that collider in that direction? Yep, you can do it the other way. On collision, on trigger, update, fixed update. So question is, now when you're doing these things, where do you check for your touching? Where do you check for your grounding and so on? Maybe it's during on enter, on exit, on stay, or in the update events. It's kind of up to you. You have to figure out, all right, how often do I want to check to see, am I grounded? Is it continuous? Does it make sense to do it? Because it is a cast. It is, it's a non-trivial thing. You're going to potentially search, do a lot of collision detection of the scene, but where, when, and how you do the checking will impact how responsive it winds up feeling. Right? So if you're only doing it at 50 times a second, or you only do it in response to certain things, it might feel different than if you're doing it, checking inside the update, which is going to be basically sort of the fastest feel-wise. So I mentioned teetering before. Kind of cool, fancy behavior. You might think, oh, that sounds, never. If you've ever played Sonic, probably lots of other games as well. Teetering is a real thing, right? Let you know, okay, I'm kind of hanging off the edge. Consider the relationship of the point of contact to the center of mass of the object. You can use a variety of different checks to do that sort of thing. Also played a bit of Minecraft lately. I know, like in Minecraft, you can hold one of the shift keys, and you kind of move to the edge and kind of see over the edge, so it kind of modifies your collider, so it has to know, all right, things are okay. I'm not sure how much of that is really, but it is those edge conditions make all the difference, when you're trying to move around carefully, quickly, stealthily, right? Provide a lot of the character's character, right? What it does. So there is another version. If you want to see yet another crazy method, there's a YouTube video out there, feet on the ground, casting, climbing, overlapping, and so on. Another one is so. Too long, didn't read version lecture. I think that one, I don't know how long, just a few minutes worth. Yeah. Oh, well, no, it's still 25 minutes. I don't know. Maybe it's not. Okay. So this is a really good video. Mix and Jam actually they have lots of good videos. I haven't talked about them in a while. I should have introduced them a while ago. What Mix and Jam does in this channel, they sort of analyze various games mechanics. So like a certain blade movement, in this case Celeste's movement. I don't know if they did Mario's jump. There's another long video dedicated to how Mario jumps, how he gets his particular look and feel, exactly how it's timed. I forget here. The Celestial Brush, that's a good one. The ink system in Splatoon is a really good one. But the movement in Celeste is a really good one for this particular project, because it really gets into kind of the character control and when is it appropriate to allow the player to double jump, or how long should they be suspended in the air, or what should wall climbing feel like, even some of the cool effect you want to think about if you want to get fancy. Does he do it? Yeah, he does. Or they do. In terms of that little characters, trails, and hitting platforms and so on. Right. So this is a really, really good video that if everyone was just here, I would say let's just watch it, but since the audio usually doesn't come through to the people who are watching it online, I'm just going to reference it and let you do that. So, and let's see. That is sort of it for today. It's kind of intended today to be sort of on the light side since the project did just finish, but this is sort of a key thing to platformers. So we want to, as you're thinking, designing, creating your platformer, you certainly want to be taking into account that character control, because that's, what gives one game its real personality, how the characters interact. The game that I had done last spring now, was it? Yeah. Was sort of, well, it was definitely inspired by Sonic, using the Knuckles character. And I guess it's that one. No. I spent a lot of time deciding, all right, well, what happens when the character is in contact with different types of things, or it's in the air, or it bounces off something, or how quick does it bounce? When you let go of something, when you push off of something, it really changes the look and feel of the game, the juiciness of the character, right? In Sonic games, it's supposed to be all that kind of spinning, crazy, frenetic energy as opposed to a careful movement. So I added different types of elements to make it feel more or less weightless, right? When it jumped, or when it was in contact with certain things, when it was climbing on the walls, was it just setting gravity to zero, or was it trying to add something? I was trying to do things like negotiate or counterbalance gravity as opposed to just negating it altogether. So, this is weird. No? That is not the one I thought it was. Well, actually, I think I even left a link to it. So if you go on Discord and want to play the game, you never know what you're going to find if you look around in here. You see other people's games as well, get inspired. No. I'll have to repost this. Spring 2021 class. So he has a certain stickiness to him that if you jump when you're on a wall, for example, you can, if you're not moving in a certain direction, whoops, it'll just kind of roll, but then if you're moving in a direction and you jump, you can do all sorts of different things with regards to sticking to things. You have to sort of fine-tune exactly how it interacts with things like buoyancy colliders. So here's, I wanted to use buoyancy colliders or collisions in here, so I couldn't just, well, I can't move, oh, I could force him to go down. It's like one interesting thing. When you're floating in the air, you still want to have some kind of way of floating down. Right? So if I try to point down, I can still come down. If I'm in midair like that, I can't jump up, but I can force it to go down. Let's see, there's another way to get out of here. If I remember correctly. There we go. And there's a little bit of kind of coyote timer stuff, a little bit of getting towards the edge. You can see it doesn't immediately fall off. And then certain objects that he collides with, he throws some bombs here. So Knuckles' motion is all kind of physics-based, and he's very sticky. But the nice thing about being physics-based is that all of the things like other colliders and effectors, and like even here's sort of a magnetism. Here's a pinch point. I thought this was a fun addition. People got a kick out of this. I don't know. That if you try to, you notice he went through the pinch point, got squished, so it became half height, which is a requirement. Otherwise, he can't get through here. And the moment he goes down here, whoops. What did I do? That was weird. I entirely exited. Oh, well. I'll give you the link. You can certainly kind of check that game out, see some of the things, find some of the quirks, but it's the personality. Platformers, there's a million platformers out there and the same basic mechanic, right? It's jumping around from platform to platform. And it's always a matter of like how do you riff on that? How do you make that your own? The Celeste video is a really good one to kind of start from and get some inspiration from and say, okay, where do you want to go with it? What kind of mechanics do you want to have in there? So think about the design of your character controller just as much, if not more, than your environment design, because the two of them are going to inform one another, right? Because you say, well, how far can they jump? And then you're going to make lots and lots of decisions about your environment because, you want to make it playable, right? You want to make everything is just far enough, or it's just really, really hard to get from platform to platform, and so on. So kind of start keeping a little bit more of a design log going with that sort of in mind. And on that note, we'll call it a day and thank everyone for your attention who's here in person. Thank everybody who's here online. And hopefully we'll get all the projects graded. We'll be all caught up by Thursday, and then we'll be in good shape for the rest of the semester. I'm optimistic I'll have everything all squared away for Thursday. Any questions? No? All right. Have a great couple of days. See you on Thursday.